Hi, so welcome to this video on writing equations. And the focus of this video is going to be on writing equations. So not necessarily finding the answer, which I think is what a lot of us are going to be thinking about as we do the problems, but more about writing the equation to represent the situation. So we're going to be, I'll say that again, we're going to write the equation to represent the situation. Now sometimes being able to figure out the answer helps us to write the equation. And what the equation does for us is it gives us a model of the situation. And then if something could change, we could adjust that model and quickly solve the situation again. So that's why we write equations. But I'm kind of talking in abstract. So let's look at these problems here from your book. And this actually comes from your textbook, volume 2. We're on page 254, which is on your screen. It's right here on your screen, so you can use that as a reference. And if you don't have a physical textbook, you can always access it through the EasyBridge link also, if you just know the page number. So let's look at this situation here with Marley and Tucker and golf. So it says, what equation can be used to represent the number of golf balls in Marley's and Tucker's collection? So it's telling us that Tucker has 159 total golf balls. I know that it's right here in this graphic. Now, it's also telling us that Tucker obviously has more than Marley. I can tell from the picture. It says that Tucker has 3 more than twice Marley's collection. So if you can tell, Marley has this one basket here. We don't know how many are in the basket, but Tucker has 2 of those baskets and 3 more. So we're going to write an expression or an equation to represent that. So what we're going to do is I'm going to write out this sentence again, and then we're going to translate it. It says that Tucker has 3 more than twice what Marley has. So 3 more than twice. Well, I don't know how many are in this basket, so I'm just going to call this a basket of golf balls. So B for basket. And but I do know how much Tucker has, so we're going to get to that in a little bit. So these 3 here are not in the basket, but if he has twice those, that means that he has 2 of them. So twice what Marley has would be 2 times what Marley has. But in addition to that, Tucker also has 3 more than that. So that means you have to add these 3. That's plus 3. So 3 more than. But whenever you see this phrase more than, that's telling me that the order of these things are actually reversed. So it's like it starts with the 2 times what he has, and then 3 more than that. So even though it's written in this order, this is the order that we would represent the expression of what Tucker has. Remember, Tucker's the one that has more. Do we know how much Tucker has? Well, yeah, he has 159. So that means this represents what Tucker has. But the other thing that represents what Tucker has is the number 159. So that means these 2 things are equivalent. So now I have an equation. I know that Tucker has 2 times the number of baskets that Marley has and 3 more golf balls. And all together, when you combine all that together and count them, it's 159. So let me show you how your book does it. So your book used M for Marley, and so that they're using like this graphic of a bar graph. I mean, if that helps you and that makes sense to you, that's great. I'm not a big fan of it, but if it makes sense to you, that's good. And they're saying like what they're saying is if you take all of what Tucker has and you start putting those golf balls in a basket, it would fill this basket, which is the same as what Marley has. And then you'd start filling a second basket because you have extra. And then after the second basket was full, you'd still have 3 left out. And all together, that would be 159. That's how they're representing it. Or this is the way we did it. We said, okay, here's the amount that Tucker has. That's the same as saying twice what Marley has and 3 more. So there's the equation. Notice that their equation is written in this order. And we wrote our equation in this order. It doesn't matter which way you write it. They're both the same because the 159's on one side of the equal sign and the expressions on the other. So this is fine. This way is fine. I like it this way because when we go to solve it later, this is going to be a lot easier to solve. So there you go. There's Marley and Tucker's golf ball problem. Yay! Okay. No, not excited? Oh well. Well, let's do a try it then. So here's one of those try-its from your textbook where they have all the blanks and then you don't know what to go in them. Yay! Well, let's look at this. Cole buys a new laptop for $335. That's a total, right? Like that's like a total amount. He makes a down payment of $50. That's a one-time thing where he pays $50 one time up front in the beginning. And then he pays the rest in 6 equal monthly payments. So he takes out the rest that he owes and he breaks it up into 6 equal monthly payments and he pays them, and we're calling that P. What equation represents the relationship between the cost of the laptop and his payments? So they've created this bar graph again, and what they're saying is the total amount is $335. He's going to pay all of it eventually. First, he pays $50. Get that out of the way. And then he pays the same amount for 6 months. And that's what all these P's represent. P for how much he pays for each month. Okay, so the total cost is going to be paid off by first, the down payment came first, and then the 6 monthly payments over time. And once he completes all those, then he will have the whole thing paid off. Okay, so then here's our two values that are equal. There's the total. And the other value that's equal to that is all the payments combined together that are going to create that total. So this is where the magic happens. This is the $335 because that's the total amount. Here's the down payment that he paid up front. Plus, he's going to pay 6 monthly payments. Now, if I stop there and just write plus 6, 56 does not equal $335. You should also be aware that 6 isn't money. 6 is the number of payments or the number of months. We're doing it each month. So this 335 is dollars. This 50 is dollars. I have to add dollars to get dollars. So money plus money equals money. I can't do money plus months. So how do these months become money? Well, because each month he's paying the same amount. He's making a payment. We don't know what it is. That's the money. So the amount of money times 6 would give me how much total money he's paying in those 6 months. And then I would add that to the $50 he paid up front, and that all together would equal the $335. So when you're making these equations, you have to be thinking about the labels. So $335, and I'm not going to put the label in when I write the equation, I'm not going to use anything extra. I can write it up here when I'm figuring it out, but then I take the labels off. So that would be 6. Let's make 6 payments. Okay, a certain amount of money each. Plus $50 you paid up front. All together, that should pay off the laptop. So we just wrote 2 equations. Look at that. So your book actually has example 2 here, which I think is pretty challenging. You can feel free to read it and see how they wrote the equation for your own benefit, but we're not going to go over it together as a class. We're also not going to do the try it. We're going to jump down to example number 3. In example number 3, they have a situation, and then we're going to look at the multiple choice here and decide which one is the correct equation to represent the situation. Claire bought 8 tickets. So here I am. I'm right here. Example 3. Claire bought 8 tickets for a total cost of $104. So there's a total amount, the whole amount. She had used a coupon code for $3 off. So each ticket. So not just $3 off in general, but $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? So let's think about this, how this would work. So let's say she's buying a ticket. So I don't know how much the ticket costs. Pretend like the ticket costs, let's just make up a number. Pretend like the ticket costs $10. If the ticket costs $10 each, then what she would do is she would say, well, it cost $10 originally. Then you would take $3 off. Would that be addition or subtraction? That would be subtraction. So it would be $10 and you would subtract 3 and you get that amount. And then she would do that 8 times. So then 8 times that amount. 8 times 7 would be 56. Well, we already know then she must have bought, they must cost more than $10. Well, how do I know that? Because when I use that $10 as my example, I ended up at $56 and she owes $104. That means it must be more than $10 per ticket. Okay, so let's look at these choices. Notice how the first choice has all the numbers involved. The X for the cost for each ticket, the 8, 3, and the 104. And 104 in all these equations is the total cost. It's by itself. The total is usually by itself on one side of the equation. That's what you'll notice pretty consistently. But then on all 3 of these, they have all the other numbers we need, but they're in different places. So we have to figure out which one's correct. So 8 is the number of tickets. I notice that in some of these things, I will be subtracting X and 8. Well, what's the label on X? X is dollars. It's the cost per ticket. So that means the only thing I can take away from X is money. The only thing I can add to X is money because it is money. So that's the label there. What's something else that's money here? Well, there's the discount, which is $3 per ticket. So then what's the 8? Well, the 8 is 8 tickets. So 8 isn't the money, 8's the number of tickets. So if I was going to buy 8 tickets and they each cost X dollars, wouldn't I multiply 8 times X to find the total cost? Yeah. So why isn't that a choice? Well, because remember, she has to take away $3 per ticket because it's coming off. So I need to look for the one where there's taking $3 off each ticket and then multiplying it by 8. So I know it's not this one because this one has me subtracting money minus tickets. And that's not going to work, so it can't be this one. So now I'm down to these 2. What's the difference between this equation and this equation? Well, in this one, they're saying first, you're going to multiply 8 times X and then subtract 3 one time. So that's like one discount. But the discount was $3 off each ticket. So the thing I'm subtracting is the X, which is dollars per ticket, minus $3 per ticket. See how they have the same label? That's why I'm able to subtract them, because they have the exact same label. So X minus 3, I have to do that first, then multiply by 8. So it's this one. That is the correct equation to represent the situation. And you can see that your book does identify that one as the correct one. So there's 3 different situations that required us to represent it as an equation. After this, then eventually you'll do practice in the book where you're writing your own equations. But hopefully this gave you a good introduction to writing two-step equations. Thanks.